six rectangular strips we have kept. 6 8s are 48 and 4 cars.
To show the things in an abstract manner. Here we can show it with the concrete manner. So ma'am, if you want to ask something, you can. Otherwise, we will go towards the next group.
No, sir. That was a really very nice resource. Actually, children mostly gets confused how crossroads, especially in the case of crossroads, right? That square which comes twice, the area of that square. So that was very beautifully explained and well done, sir. We can proceed for the next group.
Okay. Now I would like to call upon group 6.
Good morning, sir. Good afternoon.
Good afternoon.
Sir, myself, I am DVR Gupta. We are presenting two projects, two ideas. A problem which is having multi-dimensional, which is needed to think in more than one dimension. This is related to LCM and HCF. One small project I am presenting on the basis of HCF. Another one is LCM. So in my group, Mr. Jyoti Prasad from Vijayanagaram, he wants to present on LCM. Myself, I am presenting on HCF. Rectangular courtyard. The shape of the floor is a rectangle. It's a courtyard. It is to be tiled, paved with the tiles. All the tiles in the market are available in the shape of square. The shape of the courtyard is rectangle. When the courtyard is to be paved with the square tiles, what is the minimum number of tiles required is the question. Example, the length is 120 feet, breadth is equal to 36 feet. Length of the courtyard is 120 feet. Width of the courtyard is 36 feet. We want to find the minimum number of tiles required, square tiles. When the minimum number of tiles are required, the size of the tile should be maximum. What is the maximum size of the tile is the question. In the same question, another part, what is the side of the square tile? Here, we need to find the HCF of the length of the courtyard and the breadth of the courtyard. Length of the courtyard and breadth of the courtyard, the HCF is exactly the side of the square tile. It is the idea. Afterwards, if each square foot, the cost is given 12 rupees, what is the cost of all the tiles required? Next, another question to follow. If for the purpose of working or the tiling purpose, it is charged rupees 12 per square foot, what is the total charge it requires for the total flooring? This is one question, madam. Mr. Jyoti Prasad from Vijayanagaram, he wants to tell on LCM. Mr. Jyoti Prasad. His idea.
Good evening to one and all. Good evening to one and all.
Good evening, sir. Good evening.
Good evening.
Myself, Bayarki Jyoti Prasad. I want to present an activity to find the LCM of two numbers, 8 and 12, by simple paper cutting method. I want to share the screen, so I'm just switching off the video. The activity is to find the LCM of two numbers. The activity is to find the LCM of two numbers 8 and 12. So first of all, here we have to make a grid of numbers from 1 to 100. And after that, we have to cut the multiples of 8, that is 8, 16, 24, 32, 40, 48, like that, up to 100, we have to cut the multiples of 8. We will make one sheet on a cardboard or piece of paper, colored paper. Then after that, we will take another sheet and we will cut all the multiples of 12. That is 12, 24, 36, 48, 60, like that up to 100. We will cut all the multiples of 12, and then we will place those two sheets upon one another. The multiples of On the multiples of 8, we will place the multiples of 12. Then we will get this one. These 4 holes we will be finding 1, 2, 3, 4. This brown color one, and in the brown color one, the least number, that is 24, that we will identify from this sheet. Here 24, that will be the LCM of the two numbers. So in this way, we will be finding the LCM of two numbers by paper cutting activity. Thank you, sir.
Madam,
Yes, thank you, sir. Jyoti Prasad, sir, that was really very nice. And it could be definitely used for smaller elementary students. Class 6 and class 7 students can be taught LCM because they are very much confused in how we can find the LCM. So that was very nice. And regarding that HCF, that was also nice. Gupta sir, presented by you. And that's it. Sumit sir, you may ask the questions.
the effort was good, but the one thing I wanted to ask Jyoti Prakash sir, for solving those questions, every time we have to make this type of resource. Means for different question we have to make different such sheets. Can we think of an idea where we can have one resource used for many places? Means it can be used for solving many questions, like group 3 members have done. That we will have one resource and we will use it in different contexts. Can we think of that?
That we have to think, sir. We have to think, and
I think
it is good, no problem.
yes, sir. I think the concept of
Yes, there is an idea, madam.
numbers or
There is an idea.
numbers.
With one idea, LCM of all the numbers can be find out.
Mhm.
Yes,
Here I have made small projects.
Yes, sir.
It's like this, madam. Two numbers. First number is a bigger number.
Mhm.
Second number is a smaller number. For example, number if it is 35 centimeters the strip we can make. Another strip is 15 centimeters. Means we need to find the LCM of 35 and 15. Make more number of 35 strips and make more number of 15 strips. This is a strip which is representing number 35. More strips, and this is representing smaller number 15. This is also required more strips. Suppose if 15 strip is sticked like this, and next it will be going on. Suppose if it is made, last 5 centimeters is left. So more strips we need. All 35 centimeter strips joined together, and all that small strips which are representing 15 centimeters go on filling. Suppose if the last stage, if it comes, both the strips are completed, there it gives exactly the LCM. For example, if I take 5 bigger strips, 5 into 35, 140 is the LCM. Suppose if I take 35 centimeters, 7. 7 into 35 is exactly LCM. Okay, madam?
Yes, sir.
Normally for HCF, we do practically an idea, but this is for LCM. Right, madam?
Yes, sir. Yes, sir. This was
Practically, we can do simple. Two numbers, we need to find LCM. For both the numbers, 2 steps we have to make. Join together all the steps. On bigger steps, simply filling on the smaller steps one after the other like this. Till we come to end where last both the steps are completely end. Count the number of bigger steps. That gives exactly the LCM. Right, madam?
Yes, sir. This was also that can be developed for some numbers, or it can be applied for larger set of numbers. That
Any number.
any number. Suppose I
Example,
want.
I have taken for 2 numbers. The same can be extended to 3 numbers or 4 numbers. Suppose the bigger number is the made step is made, it should be under subcell DJ. Above that, the next middle number. Above that, the smallest number. If there are 3 numbers, for 3 numbers, 3 different steps we need to make. For 2 numbers, 2 different kinds of steps we need to make. More steps. Normally, I teach for LCM. Suppose if 2 numbers 20 and 30, when we want to find LCM, take bigger number. Write all multiples of bigger number and compare with smaller number. Which smaller multiple is the multiple of the other number? That gives exactly the LCM. Example 20 and 30. Multiples of 30. 30, 60, 90, 120. And which multiple is the multiple for the second number? That is exactly the LCM. 30, 60, 90. 60 is multiple for 20 also. Therefore, 60 is the LCM. Same idea in practical activity way. Right?
Okay, nice, sir.
Okay, that was very nice, sir. Thank you, sir.
Thank you, madam.
Now I would like to call upon group 4. Group 4.
So for Padma madam.
Good evening, sir. Good evening, sir. Manisha
Good
madam is
evening.
explaining from the group 4 onwards, sir.
Yes, ma'am.
Okay.
All good evening, sir. Good evening to all.
Good evening, ma'am.
In this present,
Shall I present the screen, Manisha ma'am?
yes, ma'am. Yes, ma'am. Present.
Good evening, one and all. Yeah. Manisha ma'am, you can start.
Okay.
Actually, yeah.
Okay. In this presentation, we are going to show that how to use a two-dimensional figure, form a three-dimensional object, and find its area, that too without using the standard formula. And the topics which can be addressed using this resource are area and the perimeter of a square and rectangle, as well as the curved surface area of a rectangle by using the paper folding technique. So first of all, I'm going to use this square sheet, this big form, and A4 sheet. And as an example, I'm assuming that the side of the square is 2 units. Means all the sides of the square will be 2 units. And first thing, we have to fold it from the center. And when I fold this square from the center, the shape, what shape we have obtained? It is the rectangle. And now the length of the rectangle, as it was a square, and the this is the length of the square and the length of the rectangle is same. So this will be 2 units, and the breadth is exactly the half of this square. So this will be 1 unit. Now I'm going to find the area of this rectangle, that too without using the formula, that is length into breadth. So let us see how we can find the area of this rectangle. If I fold this rectangle from the midpoint like this, what shape we have obtained? It is a square. And since it is exactly again the half of this length of the rectangle, which was 2 units, so the length of means the side of the square will be 1 centimeter, and this is also, this was the earlier also it's 1 unit. So area of this square will be 1 unit square or 1 square unit. Now, but our aim is to find the area of the rectangle. So if I cut it from the center, means if I cut it this rectangle from the center, so I have obtained this square whose area is 1 square unit. And as you can see that this rectangle is exactly the double of this square. That means if I multiply the area of the square with 2, I will get the area of this rectangle. So it will be, since the area of this square was 1 square unit, here the area of this rectangle will be 2 square unit. So we just from 1 square we have found the area of this rectangle, area of the square. Now I'm going to form a cylinder with this rectangle. So if I join these two edges of the rectangle, shape which I got is a cylinder whose top and the base both are circular. Now the height of the cylinder will be the edge of this, means the breadth of this rectangle, which is 1 unit. So we have height and this is the cylinder. Now our question is that what will be the area of the cylinder without using the formula that we all know, that is 2 pi RH. So you can find the area of
Curved surface area.
Yes, ma'am.
Curved surface area.
Yes, this is
Lateral surface. Lateral surface.
this
Surface
is the
area.
use the formula 2 pi RH because it is for small children, means which do not know the formula and we don't want to apply the direct formula. Then what will be the area of this means curved surface area of the cylinder? So answer to this question is
Area of the square rectangle.
yes, sir. Yes, sir. The area of the rectangle only has cylinder. Therefore, the area of the rectangle will be actually the area of this cylinder, and we can verify this by using the formula 2 pi RH, because the circumference, actually the circumference 2 pi r is the length of the rectangle. So if I equate 2 pi r with the length, which was 2 unit, I will obtain radius to be 1 by 22. And if I put that radius and height 1 unit into the formula 2 pi RH, we are actually getting the same area which was for the rectangle. And based on this, we can frame so many questions like what is the ratio or the comparison of the areas of these two squares, means the bigger square and the smaller square. We can compare the ratio of the parameters. We can compare the surface area of the cylinder which is the depth of the rectangle or which is made of the length of the rectangle. So many questions can be framed and explained. Don't know what is the formula, means the pre-planned formula of the standard. Thank you, ma'am.
Thank you, Manisha ma'am. That was a really wonderful resource which could be definitely used to discuss the perimeter and area of a square, a rectangle, and a cylinder, of course. And we can also, from here, we can also differentiate the curved surface area of the cylinder and total surface area.
Yes, ma'am.
Yes, that could be extended, and also we could also include that idea of three-dimensional shapes, right? Because
Yes, ma'am.
yes,
Yes, ma'am.
so that was nice.
Thank you, ma'am.
But sir, okay.
Uh, the idea was nice, but at the end, the questions I did not, means I could not see the questions because they are
They were too
very
small.
small, too small to see. So if possible, ma'am, if you send those questions in the
Yes.
WhatsApp group so that I can see
Yeah,
them.
so we'll share the PPT in the WhatsApp group, sir.
Okay, okay, okay.
That will
Okay.
be fine.
Now I would like to call upon group 2.
Sir, good evening, sir. Lata madam is going to present.
Okay.
Lata madam.
Yes, sir.
Krishna sir, present this.
Good evening, sir. This is sir.
Krishna
Sir,
sir.
we have taken the topic integers number line. How to represent integers on number line? Number line is our
Madam,
resource.
one second. Presentation.
Yes, sir.
Krishna sir, present. Presenting.
Sir, आप ज़्यादा lot of sound.
Yes, sir. Can I start?
Sir, presentation, sir. Madam. You can do it.
Sir, our topic learning in this learning resource we have taken number line, sir, and in this number line we have taken topic integers. How to represent integers on number line, and after that we will continue for the various purpose also. Actually, integers, when we start, we tell children about the what actually are integers, that is positive and negative. Here it is written on the number line. You can see that it is with different colors. Blue it is for positive, and red we have taken for negative. So positive and negative are the integers here. So these integers, how we can do for the operations in mathematics, that is addition, subtraction, multiplication, and division also. So before I start, this one I have taken again a number line where if we add, how we move, and if we subtract, how we move. So addition, when we are doing, we move towards right, and when we do subtraction, we move towards left. So I have taken my example, sir. Here it is -2 plus 6. That is first example one. I have taken addition. So -2 is the first term, integer. So first from 0, that is the starting point. From 0, we move towards negative. So we go to -2, and then we are adding 6 to -2. So when we are adding, so we have to move towards our right. So we count 6 point, and then we will, where we stand, that is the answer for that problem what we have taken. -2 plus 6. So -2 towards left and +6 towards right gives 4. So one more example also, it is subtraction. So 2 minus 8. First 2 is positive. So we move towards. So for explaining the children, we can tell that 2 is positive. So move towards right to 2. And then 8 is in negative. So you move. Negative means which side we will be asking in between. So we will move towards left. Then count 8. And where you come up. So where you stand, that is your answer. So number, it is easy for explaining the children as this way. Okay, so next, sir. Next slide. Yeah. This one, I have taken a small word problem, sir. In this word problem, one second. Sir, here this is the question. I owe my brother 8 rupees. Means I should give 8 rupees to my brother. So from my side, I am giving the question. Therefore, I have to pay him 8 rupees. So pay is minus, representation it is minus. And since I have washed, that is a question, that is just, it is an application problem. So I wash his socks and he forgive rupees 5 off from that. So what is the remaining amount I should again, means I should pay. So this is the question one. Numerator, this is the application problem. So what I should give is negative minus 8. In this, again, I should give, he has owed me, he has given me 5 rupees from that, but means he has deducted 5 rupees from it. That is minus of minus 5 only. So what is the remaining left? So minus 8 minus of minus. So from mine, he is subtracting that minus 5. So comes to remaining amount, still I should pay him. It is minus 3. So that I have explained with the number line. So starting it is minus 8 I should pay. From that he has deducted 5. Means it is again coming to minus. Then leftover how much I should pay is rupees. Again it is minus 3. So still I have to pay him minus 3. That is 3 rupees I have to pay him. So this is one example of word problem. Next is it. This is simple problem. Simple, sir. This is like how we represent positive and negative. So this is like lift. So we have here how we represent positive numbers. When we go up, we represent as positive, and when we come down, it is represented as negative. So here that is a small example given here. And next one, sir. Next, these are the examples how. Now from top, whatever we have seen, those are how number line is used, how that is explained. That means in addition what we do, and in subtraction how we go, how we use the number line, and a few word problems are there based on this. A diver, actually this is diver, distance 20 feet in the water from the boat at the surface of a lake. He then rose 12 feet and descends another 18 feet at this point. What is the depth of the water? This is the problem. A diver descends. We have below and above. When we take below, we take as negative, and when we take above, it is positive. Like small examples when we give for children, like debit and credit. So for that, what are the signs we use? So those already children will be explained before, and that whatever they have learned, that they will use in this word problem. So a diver descends 20 feet in the water. Descends means he is going inside. So below means from above the lake is going inside. It takes the value of minus 20. So minus 20 feet he went inside, and then again he rose up 12 feet, means he came up 12 feet. So minus 20 plus 12. Then again another 18 feet he went inside. So what are the signs taken for these numbers? So that we can easily explain below and above, or descend and rose. So for that sign we will give for the children before. So with that, they can easily solve this type of questions. Similarly, we have another question also. A price of the stock decreases. Actually, this is number missing. 10 rupees for 4 consecutive days. What was the total change in the value of the stock over 4-day period? What will be the value of the stock after 4 days if the original value of the stock is 200? Original is 200. But 4 consecutive days, it is descending. That is, it is decreasing by 10 rupees. So each day 10 rupees, 4 days is 40 rupees. That is minus 40 he will get. So what is the original value after descending, after decreasing the amount? So it comes to 160. So small examples, either numerically or word problems also we can tell to the children in this.
Thank you, Leta ma'am. Great effort. Can you show me the slide that was coordinate wala tha, I think?
Yes, ma'am.
Can you show that?
कृष्णा सर लेटर वाला दिखाइए.
That ladder one. Actually, it was very small, so I could not say what was there.
Ma'am, this is Cartesian plane.
Okay.
Yes, that is, we have a horizontal and vertical line. So Cartesian plane divided into positive and negative, up also positive and below also negative. Na? So according to that, here first one it is given as 6. It is positive 6.
Okay. What we were trying to explain through that Cartesian plane, because you had number 9, right? So can other concepts be also explained in the number 9? You just showed addition and subtraction. Other things we also showed.
Actually, Kusuma madam, echo is coming. Please mute. One device. I think you are using multiple devices.
I think this echo is maybe research.
Okay, next.
So, Lata ma'am, I would like to ask one question. Okay, can you use the number line showing addition, subtraction, showing the integer concepts? Can it be extended to other concepts also, like fractions, decimals?
Yes, ma'am. This actually, this is like for 6th and 7th class, they're starting actually. When these integers are taught in 6th class, they don't have actually number line before. Starting when integers are taught, we use like stars, small red star, blue star, etc. And we tell them the red star we will take it as for positive, and the blue star we take it as negative. So they will bring the stars sheet, and that activity based they can use it, ma'am. Before number line, it is with stars. Then after getting to that concept, they will get little bit. They can understand from the stars what are positive and negative. Then they will get the answers from that stars only actually. Then after that, the next topic is how to represent this. So it is very that time they can understand on the number line how we can represent and how to get the answer
I
from the
wanted
number line.
just to say that this number line we start from class 6 onwards, so this could be extended till class 10 also, because we are representing rational numbers also, rational numbers also. Number line.
Yes.
So this number line is a resource which can be used for various purposes.
And this is not this, ma'am. In 10th class, now they have graphs also. So one part we take only positive side. Positive side we take and we draw bar graphs, histograms, frequency polygon, frequency curves we have. So that now we are taking one side of one quadrant. That is positive quadrant we take, and we draw this graphs for higher class.
Okay, thank you, Lata ma'am.
9th and 10th, even linear equation graph also is there, ma'am. So using for that also we use this number line.
Yes, we can represent rational numbers also. So this number line can be used in different classes.
Decimals also.
Concepts. Yes, ma'am. Yes. Okay. Yeah. Thank you so much, group 2. Now we will proceed to group number 1. You may present.
Narendra sir? Narendra sir will present, madam.
Okay.
Very good afternoon to all and all.
Good afternoon, sir.
Very good afternoon, sir. Actually, I'm going to, as a member of the group A, we 10 members were decided to present one resource, sir, which will be very useful. We hope that everybody can enjoy this one. So this is about how a student can recognize prime number, even number, odd number, and what about their factors, everything, madam. Okay, sir. So I'm going to present now, sir. And before that, I would like to ask you one question, sir, for all the teachers, because we are the maths teachers, something creativity should be there in asking questions also. Uh, on 13th December, I got a circular that KVS is conducting a 5 days workshop. What does it mean? Can anyone tell anything? On 13th December, just for fun for 2 minutes. That's all. Anybody? On 13th December, I got a circular that KVS is conducting a serial workshop for 5 days.
5 square plus 12 is equal to 13 square, sir.
Yes, ma'am. 13th on 13th December, Pythagoras theorem. 13th on 13th December means 12. 5 days workshop. Yes, 12 square plus 5 square is equal to 13 square. Thank you. Okay, ma'am. Now I'm going to present. Sir, is it visible?
For me?
No, sir.
Yes, sir. Yes, sir.
Visible, sir. You just start representing.
Okay, sir. So here, this is the activity. Now I'll present this. Yeah, this is a fun-filled activity for clarity in the concept of perfect squares done by group A. Okay, ma'am. And here, you see what are the sources we are taking here. You just see. See, ma'am, I'm taking cards, 10 cards like this. 20 cards I'm taking. Okay, with a green color one side and red color on the other side. Same card with two different colors on the two sides. Okay, so I place the cards like this, 1 to 20. And first thing is, what the first number is 1. So you have to turn the multiples of 1. All the multiples of that means 1 1 1 1 2 is also multiple, 3 is also multiple, 4 is also multiple. Then automatically you will get all the cards into red. So it means each card got one turn. So I am just noting down number of turns 1 1 1. Every card got a turn. And my next one. What is our second number now? 2. Now just turn the multiples of 2. So 2, 4. That means now they are in red color. Now all the cards are in red color. Now I am turning. I am just flipping the multiples of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So these cards 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These cards got one more turn. So I am just noting down here. 2 got one more turn. 4, 6, 8, 10, 12, 14, 16, 18, and the last one is 20. Okay, so after 2, it is now it's turned to 3. Okay, ma'am. Now what are the multiples of 3? 3, 6, 9, 12, 15, 18. Just I am turning those things, you see. 3, 6, okay, ma'am. Like that, everything. Like that, you have to continue this for all the numbers, ma'am. And you have to note down the norm. Here you have to note down the turns. What are the numbers that are getting turns? You have to. After 3, go for 4. Now 4, 6, like that. You keep on continuing turning the cards. Okay, ma'am. So at the end, after turning like this, and you have to besides that, you have to note down the number of turns also. Then at the end, okay, you see, we will get like this. See, ma'am, like this. So what you can say from this one? Anybody, what you can say from this by seeing this? The numbers in red color are the perfect squares.
Square numbers.
Yes, perfect square numbers.
Yes.
Numbers in the red color are all perfect square numbers. And when you continue, when you are noting down this number of turns here, if you observe this table, you see in red color we have odd numbers. Number of turns odd. 1, 3, 3, 5. So which numbers are getting odd number of turns? Only perfect square numbers are getting odd number of turns. Which numbers are getting only 2 turns? Prime numbers are getting only 2 turns. I think everybody is following this. Just flipping the cards, that's all, and just noting down the number of terms. Okay, ma'am. And from this you can say, we can tell how many factors this exists. Suppose it will take 6, plus 6 has 4 factors. If it is 8, 8 has 4 factors, and 9, 3 factors. So you can ask the students. Okay, you can involve so many maximum number of students. One in writing, noting down the number of terms, and one in that means how many, which numbers got the odd number of terms. Like that, you can involve more number of students in this activity, so that everybody will can understand easily. And one more thing, here it is we place some questions also, ma'am. How many times card number 1 was turned? What do we call that number? If you see here, there is only among all these, see, if you see this table, among all the numbers, only one got only one term. So there is something special is there in the, so it is neither composite nor prime number, nor, okay, ma'am. Okay, like that, if we have, see, we design some questions. How many times the prime numbered cards were turned? See, what we can say, how many times prime number card was turned? All prime numbers are turned odd number of times. See, here prime number, sorry, prime numbers are 2 times. 1, here prime number 2 is prime number 2 times, 3 is the prime number 2 times, 5 is the prime number 2 times, okay, 7 is the prime number 2 times. So we can tell about the prime numbers also with this research. We can tell about the perfect squares. You can tell about the number of factors of perfect squares. Okay, next. So very interesting questions. With help of my group members have designed here. How many times card number 8 was turned? Card number 8. See, 8. Here 4 times. Here 4 times. So it is not odd number. So definitely can say, tell that no, it is not a perfect square. Okay, like that, ma'am. You can say so many words, even numbers, odd numbers, how many factors will get, number of factors. I think with this activity, we can here one question we framed here. In a city A, according to the rule by local body, on Monday, Wednesday, and Friday, only even numbered cars should run on the road. Whereas on Tuesday, Thursday, and Saturday, odd numbered cars, and on Sunday, only perfect square numbers of cars will be allowed in order to reduce pollution. On which days you are allowed to go for a ride, and what is your vehicle number? On which days you are allowed to go for a ride, what is your vehicle number? So anybody, you can ask one student, what is your car number? Okay, suppose for the car number is 2365. So 2365, is it odd number or even number? Odd number. So on which day you can go, like that. We can involve students in knowing this. That means about this odd numbers and even numbers. Teaching about these odd numbers and even numbers. And similarly here, if my car number is 0441 and my brother's car number is 1729, here also 1729, again Ramanujam's number wantedly less, then in whose car I can go out on Sunday. So the student will come to know which one is a perfect square. So Sunday jana chahiye, so compulsory it should be a perfect square number. So perfect square usme kya hai? So we will get that some idea. Okay, ma'am. So that's all. Anything you can, if anybody wants to ask anything, you can.
Thank you, sir. That was a really wonderful concept that could be taught to the students. Yes, so many concepts like concept of even number, odd number, perfect square was very well explained. And the questions were also very good. And they were, engaging the students in thinking, okay, what is that number? How that is an even number or odd number? So they can be more clear with these concepts. So well done, sir. Great efforts by your team.
Thank you. Thank you. Thank you all. Team members.
Sir, one question.
Yes, sir.
Suppose a number is repeated 3 times. What does it mean? If a number is repeated 4 times, what does it mean? Repeated exactly 3 times. For example, a number 4 is repeated 3 times.
Yes, that's what.
It means,
yeah, if you want, I will show you again once again.
A number repeated how many times? 16. I think 8 times repeated 16. A perfect square how many times repeated? Suppose a number is repeated how many times, so that we can say it is exactly a perfect square.
I will show the tables.
Perfect square ke liye condition.
Yeah. Yes, sir.
Okay, sir.
See, sir. See, perfect square always, 3 terms, odd number of terms only you will get, sir.
Okay. Acha, then what about 16? 16, it is repeated 5 times. It is also odd number.
Yeah, odd number only, sir.
And perfect square, yes.
All odd number of times repeated or perfect squares.
Yeah, for perfect squares you will get odd number of factors only, sir, and odd number of flips. Each flip, that is term is nothing but number of factors. Factors, sir. Term means one factor.
Acha. Suppose if a number is repeated exactly 3 times, it is a perfect square of a prime number.
Yeah, you can say that.
Or an odd number.
Not like, sorry.
A prime number. One, it is a unique number, it is separate.
Yeah.
A prime number is repeated. And a square of a prime number. Square of a prime number is repeated exactly 3 times. Square of a prime number is exactly repeated 3 times.
Yes, yes.
Achha, any other odd number of times repeated is a perfect square.
Yes, definitely, sir. You take 7 also. 7 square is 49.
3 and any
3
odd
only.
number.
3
Again
only.
separated.
Yes.
Okay, sir, right.
Sir, Gupta,
Thank
sir,
you.
please repeat, sir, something you were saying. Gupta,
No, ma'am. Gupta, what sir question is, suppose 2 is a prime number. 2 square is 4. 4 is a perfect square number, no? So the number of terms will be 3 only, you'll get. Like that, if you take 7 square, 49. The number of 49 factors should be 3 here. Like that. Sir, am I right, sir? Gupta, sir?
Sir, exactly. Suppose we can say it is a frequency. If the frequency is 1, it's unique, neither prime nor composite. If the frequency is 2, it is an even number. If the frequency is 3, a prime number, the 2 a square of a square of a prime number. Any odd number is the frequency, it is a perfect square. Need not be the square of a prime number.
Yeah, sorry, sir. I got some
Sir,
network issue. Now I connect again.
can I clear it out? Sir, Gupta,
Sir, if the frequency is
please.
1, if the frequency is 1, it is neither prime nor composite, it is a unique number.
Yeah.
If the frequency is 2, it is even number.
Not only.
Frequency is 2, even number. You told the same, sir?
No.
2 or even number of times. Frequency is an even number. Frequency is an even number.
Even number, it is not a perfect square number.
It's a composite number.
No, composite
number or even number.
It could be
If the frequency is 3, if the frequency is 3,
Gupta, sir, one thing.
No, sir.
Only based on these terms, you can say one thing. If the number of terms are odd numbers, it is a perfect square.
Okay.
That's all. If the number of terms are odd numbers.
Again, a small difference I am making.
Yeah.
If the frequency is an odd number, no doubt it is a perfect square.
Yes.
Among this also, if the frequency is 3,
Yeah.
it is exactly the square of a prime number.
Yes, I got your point, sir. Yes.
Exactly the square of a prime number.
Yes, 100%, sir.
If the frequency is any other odd number, it is just perfect square.
Yes, that's all, sir.
Square of
here, 2, 4 is the
square of an even number.
Yes.
If the frequency is an odd number, it should be a square of a composite number. If the frequency is exactly 3, it is a
prime number.
A prime number.
Yes, sir, exactly.
Yes, sir.
Yeah.
Very good, sir. So nice. Nicely presented.
Sir, I am very much thankful for our because so many are there showing interest, looking at my. Thank you very much. Okay.
So, sir, the credit goes to you only, sir. You have created interest among the participants.
Yeah, thank you. My team members.
Yes, sir. Nice.
Thank you, sir. Ma'am, Kusuma, madam, you can.
Thank you, sir. Wonderful team effort. And so we are moving to the last group, maybe group number 5, right? Okay.
5, madam?
Yes, group number 5, you may present.
Yeah, Surya Prakash, sir.
Sir, namaskar.
Okay.
Hello.
Yes,
So,
sir.
Good evening, friends. Myself, Surya Prakash from KV to Nausainabad, Vishakhapatnam. So, on behalf of Group 5, I am presenting one important web tool, which is very much important, and of course, It is very useful for the teachers to explain all geometrical concepts using this web tool. So I think many of you might be knowing this about this tool, but this is a good platform to explain about this web tool in presence of all experienced teachers, so that they can share my feelings with their students, so that children can be benefited. So let me continue. Here it is. The name of this web tool is Robo Compass.
RoboCom.
So this is the outer structure of Robo Compass. So you can go through this web page on Google search if you type it. So let me present. So on Google search you can type Robo Compass. Then you can see that Robo Compass web page. Sir, is screen my screen is visible, sir, to all of you?
Yes, sir, visible.
It is visible.
Yes, madam. So when you type Google Robo Compass on Google search, and you can see this open page, you can see this page, and there you have to sign in. There you have to sign in either with the Google account, or you can sign in with the Facebook account. So somebody has to mute. Somebody has to mute. Hello.
Hello, sir.
Somebody has to mute, sir.
Okay.
Getting noise. Hello. Sir, right. So
Please.
web page will open, and you can open this account either through Google account or Facebook account or Twitter account also. Those who are having Twitter account, they can open this web page. So after login, you can open this page, login page with your name. So this is the outer structure of this Robo Compass. So it is a very good, very useful tool for the teachers to explain all geometrical concepts easily, so that children can be very attractive to see this visualization of constructions, and they can enjoy a lot, and they themselves will come forward to know the constructions and to do all the constructions. So in this, what we need to do here, it is some commanding tools. It is a commanding toolbox. So where we have to give the command. For example, if I want to mark point A, so this is here it is the commanding box. You can use this supported commands. So in order to mark a point on the plane, on the graph sheet or a square sheet, so this is the command you have to type in the commanding box. So mark A is equal to 0.34. So that point can be marked here. For example, if I type A is equal to 0.34, so that point can be seen on the graph sheet here. So as soon as if you have completed the command here, then you can see that point on the graph sheet here. Similarly, if I want to mark one more point, so if I suppose B is equal to, I want to mark one more point on the graph sheet, point -3, -3, 4. And you can see that another point which you can see on the graph sheet. Suppose if we want to draw a line passing through these points A and B, now we can give the command here. A line can be drawn. So line name is C. We give the name of line also. C is equal to line joining the points A and B. So you can see the line on the screen. So that if you keep on giving the commands related to the problem, whatever problem you have taken, so in order to solve the problem, whatever steps you followed in the normal classroom teaching, so the same commanding points you have to type here, so that the construction of the problem that can be seen on the screen visually. So for example, I made some questions for your reference. I made some questions, and whatever steps you follow, whatever commands you have given, so after completing the problem, you can watch this video, whatever you have done in this. For example, here in the first step, I have marked the point A that can be visualized on the screen. So this is the button you have to play. So and another step you have to mark. I have marked point B. Then in the third command, I have given a line joining the point A and B. So like that, if we keep on giving the commands in order to solve the construction problem, so that problem can be solved and can be visualized. And we can play that construction by this by pushing this button, by switch on this button, this play button. For example, I made so these steps these steps you have to already prepared well in advance before proceeding to the construction in the classroom. For example, here I made some constructions for your reference. In almost 6 to 10, almost all the constructions I made. So if you made these problems well in advance and keep it readily, so these problems can be explained throughout your teaching career, sir. So once you made this, then this tool can be useful forever. So no need to do in the repeated. Whenever you are teaching some problem, no need to do again all the commands. Once you have done it, and that can be saved permanently in your account. For example, these constructions I have constructed, I made in the past 6 years. For example, this question I'm going to explain. Draw a circle of given radius. So you can open this. So we can watch this. So these are the commands I have given before proceeding to the construction. So in order to do the construction, these are the steps I followed. So draw a circle of given radius. So let me play the video. So this heading is given outside. So let me continue this video. So I request all of you to watch this. So this is the test, drawing a circle of radius 3.2 centimeter. Now these are the steps I followed. First, I marked the point O is equal to 0.25. Then next arc, draw an arc 0, 3.25. Here in this command, you can see this. In order to draw an arc, so so here it is the commanding tool. You can go through this. In order to draw an arc, perpendicular line, these are the commands. Using these commands only, I prepared. So here you have to draw an arc with O as a center, and this is 3.2 is nothing but radius, which is given in the problem, and from 0 degree to minus 360 degree, it is anti-clockwise direction. So after giving this command, this circle has been completed. Then next one is so mark a point A, 5.2, 5. So this is the question.
So
and after that, to find the distance. So distance.
Can you
this is the commanding tool
play
for
the video
distance.
again?
Yes, sir. Yes, sir. Yes, sir. So this is one more arc.
Okay.
So okay, sir. I will play again. So this is the question: drawing a circle of radius 3.2 centimeter. Draw a circle of radius 3.2 centimeter. So first we have to mark a point O, 5.
So, please remove that grid.
Sir.
So 2D పైన గ్రిడ్ ఉంది కదా నొక్కేసి
Grid okay.
తీసేసాను 2D పైన గ్రిడ్ నొక్కేయండి.
Surya Prakash sir.
Sir.
Actually, minus 360 degree you have written there in the command.
Yes, sir. It is the tool, sir. It is the tool. Anti-clockwise direction only.
It is for clockwise, sir. I'm just correcting you. It is clockwise, sir.
Sir,
sir, you can take 360 out. No problem.
Sir, 360 also can take, sir. You can take.
Degree, then it is clockwise. And if it is positive 360, then it will be anti-clockwise.
Yes.
Because all the
sir,
positive
no problem, sir. Anti-clockwise and clockwise, it doesn't matter. You can take. So next to A, you can mark. A can mark any point A, 5.25. And if you want to find the distance between O and A, so you can give the command distance bracket O comma A. Then you can find the distance 3.2. It will give automatically. Matlab the radius. OA is nothing but 3.2 radius. You can see in the screen. So let me show one more example. So let me take the problem in construction circles, class 10th. So this is the here it is a problem. So there it is, draw a circle of radius 6 centimeter from a point 10 centimeter away from its center. Construct the pair of tangents to the circle and measure their lengths. So you can go through this. So first I have marked the point O2, then a circle, then mark any point P 10,2. So which is given 10, which is 10 centimeter now. So we have to take 10,2 point. If it is on the grid line, so that it is visible, sir. So here it is from 10 centimeter away from its center. That's why I have taken the point 10,2. Then I have to draw the, or you can go through this construction, sir. Better to explain. Instead of explaining, you can go through this screen.
Sir,
So here we can draw the perpendicular bisector.
sir, in the WhatsApp group, please send out so that we can go through the.
Yes, sir. Yes, sir. Yes, sir. Sure. So if construction is going on the screen like this, children will follow accordingly, and it will create interest, sir, among the students. While visualizing this construction, they'll pay some interest, and they will do the construction exactly. So this is the intersection points. So once you have given a correct command here, so definitely the problem will be coming exactly, sir. What the exact solution. So giving commanding is very much important in this tool, sir. So once you have given all the correct commands here, then problem can be solved easily and it can be easily. So somebody has to mute, sir. I'm getting noise. So finally, you can give the caption also. Length of tangents PQ is equal to PR is equal to 8 centimeters. So distance. These are the some commands. So if anybody I can show one more construction, one more file. So like this, before proceeding to the class, if you prepared these constructions well in advance in your personal account, RoboCompass account, then when the time comes, you can open this RoboCompass and you can open these questions and you can show the children and simply push the button, play button, and the construction will go on the screen. And even if we can meanwhile, while children watching this construction, we can control the children also. We can control the children also how this construction has made. So this is the thing I just want to share with you people. So if any queries from your side, you may discuss. Thank you, madam. Thank you, Kusum madam. Thank you, sir.
Thank you, Surya Prakash sir. That was really wonderful and very helpful for explaining constructions to the students.
Yes, madam. Yes,
Sir,
madam. Yes, very important.
Yes, other topics also we can use.
Yes, madam. Yes, there are other topics also we can explain this using reflection, translation, and some algebraic expressions also we can explain through this RoboCompass, madam.
Okay.
There are multiple advantages. There are multiple advantages of explaining this mathematical concepts using this RoboCompass, madam. So meanwhile, if I am getting time, and I will explain other concepts also instead of this constructions also, in addition to the constructions.
Okay, great effort, sir. So that was wonderful.
Thank you, madam.
Yes, sir.
So I think all the groups have done a nice work, and they have given a lot of effort to complete the assignments. So thank you to all the group members and the group leaders for the nice presentation.
And wonderful coordination amongst all the team members. It can also be seen. So all the very best to all of you, and thanks.
I think we came to the end of this day's session. Sir?
Sir, 1 minute. Sir, we are very thankful to the resource persons, Kusma madam and Sumit Chakravarti sir for presenting and explaining how to prepare mathematics material for this day. On the first day of this training program, you just started with your good presentation, so that the next 4 days also we will continue. Thank you very much from our school and from our participants, everyone. So again, tomorrow the class is at 10 o'clock. You all try to join by 9:50. Right? Thank you, sir. And one more request to all the participants. Whatever you presented, just you write it as a write-up in a paper, a white paper, or just type it in a window word, so that we can compile all and we will send to the JDIT or RO or whoever required. We will say forward to them regarding today's one. And I am requesting group one, just you narrate or give the report what are the things happened today, so that we will present all the 5 days reports to the AC madam or whomever requests. So this is a request from our side. Group leader, just today's proceedings, today's entire program, just narrate a brief overview. So how it was started, the inauguration, what AC madam said and principal sir said, just in few lines. Please present. Thank you, sir. Thank you very much, research persons, for taking the pains, giving the knowledge for us. Thank you very much.
And thank you all the participants.
Tomorrow at 10 o'clock. And I request all the, whatever the material you prepared, we created one email ID. Just please forward to that, so that we will compile all this. Thank you. Thank you very much.
Okay, thank you, sir. Thank you. Thank you, madam.
Thank you, sir. Thank you, madam.
Thank you, sir. Thank you, madam.
Thank you, sir.
Thank you, madam.